everyone who contributed to the work I've done. And I'd like to share my excitement. And I hope when we are done with this talk, you'll feel the same excitement and the enjoyment that I have when I do this work. And this is one of the most important topics, and probably if it becomes reality, one of the most significant events in the human history. And so I'm going to discuss a little bit of those things and see how we can go from there. Can you hear me? Are we okay?
Yes, sure.
Able to hear you properly?
Yes, I can hear you. Can you hear me now?
Sure. Yes. You can have.
Yes, sure.
All right, let's go ahead. So I want to, because this is a science fiction themed conference, I'd like to start with one of my first introduction to science fiction genre. This was back in 1985 when I watched a TV series on Doordarshan TV called Satyajit Ray Presents by the well-known filmmaker Satyajit Ray. And one of that particular TV series had a series of episodes. And one of the episodes was about an alien meeting someone and having a discussion with that person. I think I remember the name of that person also, and I think his name was Buddhinath Sharma. This TV episode was based originally on Satyajit Ray's book, Bank Babur Bandhu. And it's a translated English version is Alien. And Satyajit Ray, when he wrote this in 1965, wanted to make this into a Hollywood movie and even went to Hollywood to bring this, his novel, his short story into a movie. And it fell off after some time for various reasons. And so I still remember this episode after 35 years. So that tells us, something about how impactful that particular story was. And this is one of the most important ones that I could think about when I think about science fiction, my interest in science fiction. And as I grew up, there were several other science fiction books I started reading. Okay. So there were several other books I started reading, and some of you are probably familiar with many of these or some.
So you're muted. So please unmute and speak.
Ravikapur, unmute yourself.
Can you hear
me? Fine. Yeah, fine.
Okay, so looks like oops.
Sorry.
Okay, so let's go back here. Okay, can you hear me now?
Yeah.
Okay, great. So one of these are the several books I read over time to increase my interest in science fiction. And this actually inspired me to write my own stories in the last couple of years to follow the science fiction themes. And in my native language, Telugu, I'm actually from Andhra originally. So I started writing science fiction books, and this is the link and the web page I have where I post my science fiction stories. All of them have twists at the end if you're interested and read Telugu. There are some I've translated into other languages. If this is one of the events for our book list, then I'm sure there are other books that we have in Indian science fiction that I have not read, but because I have not come across them. If based on this, there is a common theme in all these science fiction stories. In particular, I'm mostly focusing on the science fiction stories that discuss aliens and alien civilizations. And so the common theme about in these science fiction stories that deal with aliens is that, number one, there are advanced civilizations. They assume there are advanced civilizations already. And then not only that, They assume that the advanced civilizations are far ahead in technological maturity than our own civilization right now. So they are super technologically advanced. This is the assumption many of the science fiction stories make. Also, in most cases, they find us and or visit Earth. Like in, for example, Satyajit Ray's story, the alien visits us, which means they have the capability to travel interstellar distances. They're huge, and they already found us to travel to this planet, right? And so, in most cases, they assume that they find us and they visit. And another point is that in many of the science fiction stories, they assume that the aliens are either benevolent, which means they are not harmful, or malevolent, which means they could be evil, like in movies, Hollywood movies that we see. There are some few exceptions, not all of them are like that, but in most of the science fiction stories, we see all these major themes. They know we are here. They are way more mature technologically. They find us. They have the capability to detect us, and some of them are good, some of them are not good. That's great. Now, how much of this is real fiction and how much of this is reality? And how close are we to reality on all these assumptions? So that is the point of my talk right now. And so there are only very few things that we can actually discuss on this one, because based on the data we have right now. So let's tackle with each one of them. All right, first of all, do we know if there are planets around other stars? Because the aliens have to live on something, right? So, well, it does look like, based on the recent surveys of NASA missions and other missions, they looked at the planets orbiting other stars. And it looks like almost every star in our galaxy has a planet around it. It doesn't matter what kind of a planet. There is a planet, and for every star in our galaxy. Our galaxy has about 100 billion stars at the minimum. So there are probably at the minimum 100 billion planets in our galaxy. And some of them could be habitable. Some of them may not be, because they are gas giants like our Jupiter. That's great. So we now know at least that there are planets around other stars, and there are plenty of them. The second question is, do we know if there are any habitable planets out of these billions and billions of planets in the galaxies? So what do I mean by habitable? When I say habitable planet, it means planets that are small in size, similar to Earth, and could sustain liquid water on the surface. Now you can see how politically correct I am here. I'm saying liquid water on the surface. The reason for that is water is an essential ingredient for every living being that we know of, right? And so when we talk about habitable planets, we want to have liquid water on that, so that life can sustain on it. So how many of these are habitable planets out of these billions of them? Here it is. We published a paper just a month ago, and that got some news actually. Let me see if I cannot move this. And one of the points of this paper that we published is that there could be 300 habitable zone planets in our galaxy. So remember, billion stars, right? Out of those 100 billion, there could be at least 300 million potentially habitable planet. And that caused some exciting news in New York Times and CNN. And that's the link to our paper that we have published there. And so the planets, these, by the way, these are conservative numbers, which means at the minimum we have 300 million, and it looks like there are 3 or 4 times more than this number habitable planets in our galaxy. Not only that, so my screen is, one of this screen thing is blocking the text I wrote here. Not only that, there could be about 4 habitable zone planets within 30 light years from Earth, according to our estimates. This is based on NASA's Kepler mission. We have analyzed the data, and we found that at least there could be 4 habitable zone planets within 30 light years from Earth. And they might be around sun-like stars. And so this is quite exciting. So we know there are planets, we know there are habitable zone planets, and not only there are plenty of them, not only that, we know there some of them are pretty close to us. 30 light years is, detectable distance with our telescopes. Very nice. Now here's a question that we are all wanting to know on all the science fiction themes. Do we know if they have life on any of these habitable zone planets? When I say life, I want to know intelligent life or not. So microbial life may be common. We don't know that. But we want to know if there is intelligent life or not on these habitable zone planets. But here is an important point that we need to make, we need to think about. If we are thinking about aliens, advanced aliens, or even aliens of our level of civilization, we want to detect the technology than intelligence. It's hard to detect intelligence, but it is within our capability to detect technological civilization, right? I mean, if I ask you, can you detect an intelligence on Earth? How would you do that? Well, you will take instruments and go to someone, or go to a species, let's say dolphins or chimpanzees. You measure their behavior, you observe their behavior, or you analyze their vocal cords or whatever. So you use technology, right? So we are trying to come up with, when we are trying to answer the question of intelligence, finding intelligent life on other planets, what we are intrinsically in the background thinking is that we want to detect the technological advances and technology of the species. And so the search for extraterrestrial intelligence, you may have heard this since a long time, is going on currently and has been going on for the past several decades. So the SETI is search for extraterrestrial intelligence, but what we should be doing is SETI, which is search for extraterrestrial technology, because that's what we can detect remotely. If we want to detect a remote civilization on somewhere on a distant planet, we can detect their intelligence. Their intelligence is manifested in terms of technology, and that's what we were trying to look for them. And so the search for extraterrestrial technology gives rise to something called technosignatures, which is essentially like a biosignature. A biosignature is something biology causes. It's a signature that biology causes so that we can detect it. If you go to a lake, a pond, and take a sample of the pond's water and analyze in microscope, you will find biosignatures because there could be life on them, right? And if you go to Mars, ISRO is sending a couple of spacecrafts. Several countries have sent there too. But if you land on Mars and try to find life on the Martian surface, then you will try to analyze something and find biosignatures. Try to find biosignatures. Similarly, we want to find technosignatures. Similar to biosignatures, technosignatures refer to any observational signs of extraterrestrial technology that we can detect. So what are the kinds of technosignatures that we can detect then? Well, we need to start with something that looks similar to Earth's technology, because that is what we know, right? Can we imagine a technology that we cannot even imagine? For example, if you go just 400 years ago or 300 years back into the past, and tell them about anyone who you meet 300 years back about internet, or Zoom video calls, or some sort of even cars, they would not even understand what is going on. So it is hard for them 300 years ago to even imagine a technology like an internet or an information technology. And so it is similarly probably hard for us to even imagine a technology that we can't even yet imagine other species could have. And so, but we still have to try, extrapolate from what we have. If you ask someone 300 years ago, what is the best technology that you can think about? They will say, well, that could be probably the fastest horse buggy I can think about. That's the best technology they have. And if you ask them what is the best technology you can use to travel or even go faster. They cannot think about something that can fly. They can only think about something that can drive on the surface of the planet. So what are the kinds of technologies that we can think then? Well, you've all heard about the radio SETI search, the search for extraterrestrial intelligence, the SETI, using radio telescopes. We have, if you have seen the movie Contact, where Jodie Foster acts as a radio astronomer who is trying to detect signals from extraterrestrial civilizations. The story is based on an actual scientist called Jill Tarter. She's one of the leading scientists in the radio search for extraterrestrial intelligence. And she is one of the pioneers of this advanced work. And so one of the technosignatures could be aliens could communicate with us with radio waves, just like we are doing right now, trying to communicate with radio waves. This is similar to our radio Earth technology. And so we are just assuming the same technology for other civilizations as well. If we can do it, they can do it. So that's one type of technosignatures. The other one is similar to, continuing with the radio technosignatures. We have sent a message to a globular cluster of stars in 1973 using the Arecibo radio telescope that unfortunately collapsed last week. If you have heard about it, now it's no longer operational. The radio message was sent to globular cluster in 1973 from this Arecibo telescope, which is 25,000 light years away. And they sent a message. If you see at the right-hand side, you see these coded message where the coded message has information about where our solar system is. The top white things are numbers 1 to 3, and the remaining things are where our solar system is located, how human structure is, what is the DNA look like for humans or in the life on this planet, and which dish was used, and so on. And recently, in the last 5 or 6 years, billionaires private investors have come into picture to fund this, looking for extraterrestrial civilizations that can send radio messages. One of them is Yuri Milner. He invested about $100 million in some initiatives called breakthrough initiatives, where he started Breakthrough Listen, which means that he funded some radio telescopes to look and listen for radio waves coming from any potential advanced civilizations. He also started something called Breakthrough Starshot, which means where they were going to send small nanoprobes with solar sails attached to them to the nearest star, which is a Proxima Centauri B, in the next 20 years or so that it will take only 20 years. They travel at the 20% the speed of light in 20 years, and they would reach the nearest star and spend about a day or two and just, pass away the system. So that's one of the things that these private investors could do. So that's another form of, trying to find out if there is a technological civilization on other planets. Well, that's all great. This is all radio communication. But like I said, we are looking for SETI, which is Search for Extraterrestrial Technology. One of the things that advanced civilizations can do is that they can build these swarm of small energy absorbing materials around their star, so that they can absorb most of the energy from the star and then send it to their home planet inside this sphere to use energy for their own purpose. And because they are absorbing so much solar energy or star energy, the whole thing sphere can heat up and emit waste, thermodynamics, right? So the second law of thermodynamics has to work here. And so we can detect them with this waste heat detection in the infrared, because of if they have constructed this kind of a huge spherical objects. Where does this idea come from? Well, there was this Russian scientist in 1960s who came up with this thing called Kardashev civilizations. With there are three, according to him, there are three types of civilizations in our, out there. The first civilization is called Type 1, where they use most of the energy on their planet. That is about 10 to the 16 watts of an Earth-sized planet. There is a second type of civilization, Type 2, where they use most of the energy from their star, the Dyson sphere we were talking about. And there's a third type of civilization, which I call them as godlike civilizations, where they use most of the energy from their host galaxy. Currently, apparently, according to Carl Sagan, Earth is in type 0.73. We are not even type 1 yet. We are using Earth's energy a lot, but we are not there yet, where we have not completely used most of the energy coming out of the geothermal energy, wind energy, solar energy, ocean energy, everything. We are not there yet. We are almost there. We are about 75% out there. This is great. So maybe we can find some civilizations that are in these different types of evolution. But the question then is it sustainable? How long can you sustain as a civilization if you're just using up all the energy on the planet, and you will heat up the planet because you're using so much energy? You have to have waste heat. Anything has to emit waste heat. There is nothing that is completely smooth and efficient without zero loss, right? And so energy is transferable. So we will be heating up the planet. So is it sustainable if we are going to use all that energy on a home planet? So that's a question that we need to think about. If we are thinking about that, then we have to question that whether can civilization live longer if they keep using energy all the time. That means if the civilization really want to survive, they have to live in harmony with their planet. So as they grow, they can't just completely pillage their planet. And so they may not emit as much waste heat energy. And so that means maybe they are harder to detect. So maybe there are so many civilizations around us, but they are hard to detect because they have learned to maintain in harmony with their planets. And so they don't emit that much energy, waste energy, for us to detect them. And so there are other types of technosignatures as well. One is night lights. Just like we have, so many night lights. If you go to space station and look at the Earth in nighttime, you would see this picture over there on the left-hand side. Brilliant lights. So maybe we can use our telescopes to find night lights on the planet. There are really some people doing this, and it may be possible. I mean, sodium lamps apparently can be detected at interstellar distances. There is also another technology that alien civilization can think about. Laser pulses, for example. They can send pulses of lasers in a Morse code kind of way. They don't know what a Morse code is, of course, but they have their own way. Maybe they send prime numbers, who knows? So they can send laser pulses to us in such a way that we can detect them, and that can only arise from an advanced intelligent civilization. So that's a technology. There's also another technology which is just like Voyager and Pioneer probes, or we are sending them outside the solar system. They keep traveling for thousands and thousands of years. Maybe some of the civilizations have sent probes to our solar system, just like we are doing that. And maybe they are out there in our solar system. We haven't looked properly. So these are the probes. This is another way of finding technology of the advanced civilizations. Look for these probes, and you might find some of them. There is really a work going on this, actually. And if we have time, I'll come to a slide where I can show you what are the efforts that are going on from NASA side to detect technosignatures. This is a serious thing going on right now. There is another one which I am actually working on right now. There's a paper in review that during the COVID pandemic, pollution decreased between 20 to 40% over urban areas around the globe. Because of the lockdowns, factories stopped, cars stopped running, transportation, everything paused. And because of that, pollution dropped down. So NASA satellites found this animation, and you can see on this left-hand side animation, as time goes on, the amount of pollution around in major metropolitan cities over India and also around China started decreasing. And so what I thought was, well, this is a great idea. Why to waste a pandemic time? And so what we do that is that, can we use this lessons learned to find other civilizations? What if there is a civilization that has about our level of pollution in nitrogen dioxide? Actually, that is the pollution I'm talking about. What if there is a civilization that emits the nitrogen dioxide pollutants into the atmosphere just like us? Can we detect it with upcoming telescopes? And that's a plot over here. We don't have to go through it. Essentially, what my paper shows is that yes, we can. Within 10, not 10, 30 light years, we are able to detect Earth level pollution on a planet if it exists. If there is a civilization on that planet within 30 light years, we may be able to find this industrial activity on a planet, a habitable planet. Okay, all of this is fine. We are trying to find them. The question then is, why haven't they found or contacted us? Just like, I mean, these are our efforts. Why haven't we seen any sort of communication from them at all? We should have found them already, right? Or they should have found us already. Well, I've gone through this in several talks, but this is a kind of a new audience, and there's a spin actually in this one. So why haven't they found us? Why haven't we seen them? Well, a couple of reasons. Maybe one of them is life is really hard to arise. Maybe there's nobody out there. It's just us. Well, there is another point, which is that intelligent life is uncommon. So maybe most of the planets, the 300 million habitable zone planets I was talking about, most of them have only microbial life. And so very, very few planets have intelligent life on them. Just to communicate with the nearest star to us, the Proxima Centauri, it takes about 4 years to send a message, even with the radio telescopes, right? And then we have to wait for them, and then they will have to reply back. So that takes another 4.2 years. So that's about 8 to 10 years for us to even communicate, to say hello to them. And so life is hard to arise, which means microbial life is so common. Intelligent life is uncommon. Probably intelligent life is very not common in the universe. And so that's why we are not hearing from anyone. It could also be that it is really hard to travel or communicate and becomes really expensive. Like I said, if you take the fastest human-made spacecraft, which is the New Horizons spacecraft sent to Pluto, if you take that spacecraft and travel to the nearest star, the Proxima Centauri, it takes about 70,000 years right now. And so if that is that hard to travel, how is it even possible for us to even have a communication with an advanced civilization? So we need to increase our travel time, decrease our travel time, and increase our speed. The other thing which is my favorite is that we did not search long enough. So we started radio communication only 70 years ago. 70 years. Our whole human civilization is 10,000 years old, starting from the agricultural revolution. So 70 years out of 10,000 is 0.007%. So that's pretty small. And so we need to wait and look long enough for alien civilizations to discover us. The other argument is a great filter argument, which is what I discussed about the Dyson spheres, where civilizations grow to a certain point, but they use so much resources, so much of the planet's energy, that they destroy themselves. Which means that they cannot. There may be civilizations growing everywhere. So easy to grow civilization. But then once every civilization reaches a point, a technological point, suddenly something happens because they self-destruct themselves and then they die off. And so maybe that's why we are not able to hear from them. So the question now here is, are we there? Or is the great filter behind us? We have already crossed it. Who knows? And one of the things that some people are saying that if we find life on Mars, even microbial life on Mars, that is really bad. Why? Because if there is life discovered on Mars, even if microbial life, That means that life is easy to arise. We found one life, on our next door planet, which means life should be pretty common, microbial life, even any life, which means the great filter, which means the filter that stops life from advancing is not at the microbial point. It is much ahead than us. So it could be in front of us now. So that is one of the reasons people think that, having finding, microbial life on Martian surface could be a bad thing. I am not into that, but people have their own opinions. So here is the other thing is, do we know how to recognize them? Just like I was talking about, if you take a technology 300 years ago and show it to people over there at that time, they won't know what is happening. So here is the thing. Look at these cards and see what is the sum of the numbers, assuming A equal to 1. You'll come up with a number here. So we are looking for that. But have you noticed that the number 4 has a black heart? So this is called inattentional blindness. Some of you may have already recognized it, simple example. But this is something called inattentional blindness. We may be distracted with a question that we want to understand, but at the same time, the answer may already be there. We are not even able to recognize it right in front of our eyes. So the point here is that we recognize the things we know, and to find the non-obvious, we have to look for an anomaly. So for example, if we are looking for alien life, alien civilizations, we are looking for technology that is similar to our Earth. But if there is a technology that our minds can't even imagine, then we won't know that we have already detected alien civilizations already. Imagine a tribal people living on a remote island, and if they see a plane flying above it and multiple times, they'll think it's part of the nature. It's a bird. And so how are they going to imagine something called a plane if they have never advanced to the point to even understand the basic laws of physics? So this is a question that we need to ask ourselves. Have we already detected alien civilizations? Is there something in our data that looks strange, but we just threw it out because it doesn't match with our idea of what a detection could be, what our idea of alien technologies detectability could be. And so we need to watch for that. And so I'll come back to the science fiction. In science fiction, we discuss about all these advanced technologies and the things that we can imagine and so on. But there are some things that are unknown unknowns. And that is what we need to look for. And that is where I think the discoveries of alien civilization could lie. Remember that the first exoplanet, for example, was discovered not because they were looking for it, because people accidentally found them. The same thing with pulsars, where they accidentally found them and thought it was coming from little green men from Mars. And so in future, I think when we detect an alien civilization, we would be finding it from unexpected source, something they were not even looking for, and suddenly think about, oh my God, what is this? And so this is where the science fiction meets science reality. Our science fiction is giving us ideas of different framework of ideas to look for what kind of things we can look for. And if we have to learn lessons from them, it is that, expect the unexpected. The point here is that the universe does not care about our expectations. It will give us what it wants to give. And it is our job to carefully look at it and see what we can find in there. I'd like to point in my last slide here that it is worth pointing out that the obvious question, are we alone, is a question posed by a technological civilization, right? Whenever people talk about finding life on other planets, they say, oh, we want to answer the question, are we alone? What exactly are you asking here? Who is asking this question? Are we alone? The microbial life or the advanced technological life on this planet? And so we have to think about this and make sure that when we are looking for life on other planets, we might even find advanced life first than the microbial life later. So The question, are we alone? It is not an if, and it is just, but when we will find it. I'd like to stop over here and ask for any questions.
I will read it for you, sir. There are a few questions in the chat box.
Oh, sure.
Sir, you mentioned microbial life could be common. Has it been detected that the microbial life in any of those potential habitable planets, 300 million, or in 4 habitable planets? If so, how many planets?
We have not detected yet, but we are in the process of building the telescopes to detect that kind of life, any kind of life, not just microbial life, any kind of life on the planets. And so those are the ones that Professor Dodamani read in my CV. That's the LUVOIR. That's the Lunar Space Telescope. That's a big, it's like, 5 to 6 times bigger than Hubble Space Telescope. We are designing now. We approached to Congress. We are in the study phase actually. And whenever we get approval, that telescope would be able to look at these distant planets, look at their atmospheres, and find life on them, find the gases on that that can give us information about life on them.
Sir, there are rumors that are going on internet. Is that Area 51 in USA really working regarding aliens or related research?
So as far as I know, Area 51 is a military facility, and that's all I can say.
Sir, are there any information theoretic methods, like for example, entropic evidence on symbols or machine learning method to search for technosignatures of alien civilization?
That's a super excellent question, because there are actually people who are applying machine learning techniques to look for these anomalous signals in Kepler data, or in the data that we use to find planets around other stars. I have not shown one particular, oops, here you go, slide. I thought maybe it will be too much, but maybe because someone asked this, I am going to show you a slide that I've given just last week at a different meeting. This one is where, oops, I don't know if I can, yeah. This one is about a structure where if you have a planet going in front of the star, you will see that sphere. And so you can see a nice curve, a U curve on the left-hand side. But if you see a triangle-shaped object crossing in front of the star, that will look different. The data will look different. So there are people who are applying machine learning to find these kind of structures around other stars. So yeah, there is a work going on, and it is one of the front-end cutting-edge work. Excellent question.
Sir, can travel in space be faster using warp technology or magnetic propulsion?
So warp technology, we don't know how to do that yet, at least to my knowledge. The magnetic propulsion, you need a lot of energy for that. And the fundamental problem with interstellar travel is, where do you get the energy from? What is the fuel source? So if we can solve it, I think we can solve interstellar travel.
Sir, isn't it possible that we have already been detected by other intelligent life and are under observation?
That's another excellent question. I'm so glad everyone is thinking about this.
One second. Our Vice Chancellor has joined.
Sure.
Professor Venugopal, sir. Welcome you, sir, actually. Sir, mute. Sir.
Yeah, I'm there.
Yeah, fine, sir.
Good morning.
Fine,
Good.
Ravi Vice Chancellor is there.
Oh, hi.
Malavika, you can take some questions directly from the participants. Then we'll go through the chat box.
Hello, how are you doing?
If anyone wishes to unmute themselves and ask question, that can be done now.
Yes. Or raise your hand, we will unmute yours.
Yes.
Ravi, sir?
Yes, I can hear you.
No, our earlier registrar, Professor B.K. Ravi is there.
Oh, sorry. Could you repeat the question?
Yeah.
I kind of lost.
Sure.
Do you want me to repeat the question, sir?
Yes, could you repeat the question?
Yes, sir. Isn't it possible that we have already been detected by other intelligent life and are under observation?
Yes, I think it is possible. The reason for that is that, if we can think about launching telescopes and looking for life on other planets within the last 50 years of our, 60 or 100 years of our technology developed so far, they have already done this. They already know, probably, we are already here. It is quite possible.
Sir, with regard to humans going into space, are human beings capable of withstanding the amount of radiation exposure in the Van Allen radiation belt? Because a fraction of the exposure, more than 10 GeV, would lead to acute radiation sickness and be fatal on Earth.
Yes, so we have astronauts in the International Space Station exposed to radiation. So we have good radiation protective technologies and shields. As long as we are not exposed for a significant amount of time in space and have a good protective layer, it is possible to do that. We are thinking about Mars missions, right? So Mars missions take months. And so it is, I'm sure NASA and other private agencies are thinking about this radiation protection.
So, Ravi Koparapu, good morning. And very happy that you are all, we have joined our program. It is really, I'm delighted that you are there with Bangalore University. My question is, can there be other forms of life other than carbon, hydrogen, oxygen?
That is a really nice question, because there could be. If you want a short answer, there could be, right? The question is, if you're asking me,
so
go ahead.
Will that type of life be better than our life, or it will be superior to our life, or whether we'll be able to compete with that type of technology or the organic technology?
I'm sure that life must also be thinking the same thing about us.
Okay.
Right, because we know how to detect.
Because when you talk about
yeah, go ahead, sir.
When you talk about aliens, we do not know the type of chemical that they are. I mean, we are trying to visualize that they are made up of a different type of chemical. We are made up of carbon, hydrogen, oxygen. The aliens, we believe that they are made up of different type of chemicals. And we always feel that the aliens might overpower us, or we might be much superior to them. So my question is, if there are different forms of life, what type of combat will you expect in future?
What type of combat? I would expect to collaborate with us. Combat.
Whether it will be a biological war, or whether it will be a war with weapons, or whether it will just, you don't require any type of war, you'll automatically degenerate and you'll get extinct when this type of two lives come in contact with each other.
So if they want to come visit us, they won't come visit here to destroy us, because it costs so much energy to come here. So I would say, if they are risking so much of their lifetime, then I think they are here for building collaboration, because it takes a lot of energy.
Okay. Another question is,
yeah.
Why is H2O so simple in any of the planets? We always think, when you think of a planet, we are talking about H2O, whether water is available there. Why do you feel that these two elements are so dear to every one of us? Whenever you talk about a planet, we are trying to search for water.
Right, because water is, every life on the earth is based on water. We don't know any other kind of life. So I was telling someone that, imagine this. I'll give an example of a party. If you are going to a party, someone called you, and you don't know anyone in that party. What do you do? The first thing you do is to go to someone that you recognize, and so that you can start a conversation. Same thing. We are trying to find something we know, which is water-based life, and from there we will go and look for something that is, completely different than what we can think about.
So this thing is, when we are made up of CH2O,
Yeah.
CHO, we are talking about HO, that is hydrogen and water. Only carbon is away from it, and we are very dear to H2O. So if there is a silicon-like life, so what will be dear to that?
For silicon life, then it will probably the silicate material, rocks, magnesium, silicate material.
Okay.
Those are excellent.
Thank you.
This is what we are actually trying to solve with our space telescope. So these are really good questions.
Okay.
Can I take more questions?
Hello.
Yeah. Usha Devi, unmute. Usha, unmute. Usha, unmute.
I asked about information technology methods. In that sense, I meant entropic evidence for some kind of ancient civilization. There was a paper on entropic evidence for linguistic structure in the Indus script by Rao et al., Washington, Seattle Computer Science Group. So in similar sense, we may have some cognitive evidences using information technology. In this sense, some symbols which can be decoded from some alien civilization. So are there any such attempts is one question.
Yes. So your question is related to a little bit related to the one that I talked about, something that we don't even think about looking for, because the way we interpret the linguistics could be something that we all
some
think
symbols.
about physics and math and technology, but then the way you are suggesting is actually being starting up right now to get a new perspective of how can we recognize something in
relation to what we know.
Correct. So there is some methodology and initial research work starting up. We just started this last year. I'm not involved in that. Someone else is doing it. But I know people who are involved in this one, and they started just this year on looking for it. This is pretty new, very fresh. So
okay, my supplementary question, Usha. My supplementary question, say that means the entire space is with the electromagnetic waves. So wherever the planets and stars are there, the electromagnetic waves. So if these electromagnetic waves are carrying signals, then we must be knowing how to differentiate what are the signals which we are transmitting and signals which are others which are mixed with this language or symbols or anything. So have you identified those signals which are disparate or different from the signals which are passing through electromagnetic waves on our Earth and between the planets and stars?
Yes, and that is the radio search SETI, the SETI search, radio SETI search for extraterrestrial intelligence. We know which band wavelength radio waves we send. Now we need to find out what is the wavelength bands that they are sending, and if we interpret it, which is coming back to Professor Usha's question. How do we interpret the radios coming from other civilizations? Based on what we are sending, is it going to be the same or not?
So we may not be having equipments to detect that range of bandwidth and that range of frequencies that is used by the aliens.
I think a bigger problem is not just the equipment. Can we even recognize if there is a pattern in there? Okay. Let's say we have the best equipment, Indian government and US government, everyone spends a lot of billions of dollars on it. Best and most sensitive equipment, but no matter how much money they can spend, our minds are not going to be able to detect the patterns. It doesn't matter. So it is our inbuilt. It's in our human nature. That's how we were built. That's how our evolution started building up. So we need to train ourselves to recognize patterns that are something totally unique. So that is why, you know, we are scientists, to find something that is totally different.
Thank you, sir.
Yes.
Krishnamurthy, please.
Yes, sir. Good morning, sir. Thank you so much for such a wonderful talk. My question here is actually the pyramids of Egypt. They were built by. There are newses we have read, and people say that those construction of such a huge pyramids, it is not that easy. It was not that easy for the people like us. So that could be due to the different kind of species or aliens, or maybe a well advanced technology during those days only, those years only. So what do you say about these things?
I say that we are underestimating our ancestors.
Yes.
Because it is not impossible for them to do this. People forget how much time they had, because we are so busy with our today's level of, go to office, gets ready, go to college, grade these papers, have this exam.
In the last 2 years, I went from being in the job.
Okay. So we are so busy. We think that, in that small, we don't have much time, and we are thinking in that small time frame. But imagine, they have nothing. They had nothing in their times. What they did was get up in the morning, start and think about how to track the sun. For example, just 3 weeks ago, my son, who is 11 years old, I took him out because this is COVID there at home. He was bored. I took him out. I planted a long stick. We have a big yard. I planted a long stick there, and asked him to measure the length of a shadow at 10 o'clock and length of the shadow at 11 o'clock. He didn't know why, he was not asking why. He just did it. And then just based on that shadow length within 1 hour, I showed him how to calculate the rotation period of the Earth. We got 20 hours. So just if you go, even you can do it in your house backyard, just point some stick and you can measure it. So all they needed to know was geometry and math and lots of time. I had lots of time now during the pandemic, so I was able to do. Now we are measuring the obliquity of the Earth just based on shadows again. And we are taking data every day of how the length of the shadow is changing. We will do that. We already took a 1 month set of data of length of the shadow with my son. So if I have that time right now to do this, imagine no computers, no internet, nothing, no distractions, no TV, no WhatsApp, nothing. What did they do? All they did was observe the motion of the stars, invented geometry, and they could build pyramids. So there is nothing, we don't need any outside extraterrestrial help to build pyramids. We know geometry by that time. We know math by that time.
No, the supplementary question is, how did they take 10 ton of stone, great this thing, to the top of, able to get that accuracy of less than 0.001 degree to the North Pole, when the base of the pyramid is about 13 kilometers and is square kilometers, and the top of the pyramid points exactly to the North Pole, and the slabs and the stone slabs were more than 10 tons. And how did it reach there if even the present equipments are not able to do it? That equipment should have been found somewhere, or it should be some type of horses or elephants or slavery. The thousands of people would have pulled it to the top. How is that possible? We are not able to imagine.
Okay, so here it is. They were able to do it from the Nile River because Nile was the closest river they had. So they transported based on the wheels. They built a barge that could, even on the land, you can slide them, the big rocks. And then they were able to transport them in that way. Pyramids didn't take 1 year or 2 years or 5 years or 10 years. They took 25 years to build. Okay. And so in 25 years is 25 times 365 days. So that's like 10,000 days or something. In those 10,000 days, they were able to transport them. Not only that, you are asking about where were the tools, right? They did find some
Yes.
tools inside the pyramids. And unfortunately, many of the tools were based on wood and rock. And because of the time, 5,000 years, many of the tools just disintegrated. The only tools, some of them survived, luckily, we still find them. And they used, in fact, the tool. So there was a nature program, a documentary, where they used the tools that the ancient civilizations used, and they were able to build the pyramid structure. And the other thing is, some of these pyramids, not the ones that we can think of, were not built from base to the top. They try to build the pyramids from top to the bottom. They removed, they chose a mountain or some place where there is just chiseled, and then try to make from the top to the bottom, while at the same time trying to make the shape accordingly the astronomical sky charts. They knew about the sky already. I mean, if I can do it, I'm no match to the ancient civilizations, math and science. If I can do it with my son in the backyard, I mean, with a 1% error bar, with 10,000 people in 25 years, that is, I personally think that they are fantastic mathematicians.
So this is a very, excellent approach. Top to bottom. They did not build from bottom to top just like we are doing. They built it from top to bottom, and that is a revolutionary idea which they had. So that is exactly diametrically opposite to what we are thinking now and we are trying to do.
That's right. Because when you build from top to bottom, what happens is you automatically build standing stages, because the rock falls down. The material, when you're chiseling, you can stand on that rock and keep chiseling it. And as you keep building it, you're standing on more and more pile of rocks. So you don't need any more stands to go up to the top. You're automatically building it. So it's a fantastic. I'm telling you, they were brilliant.
So this is exactly, but whatever we are thinking that the stones were lifted up and were pulled by the hundreds of elephants. That is not true, because it cannot happen.
Right. You don't. First of all, elephants can survive in that dry climate. So
Yes.
and so it was mostly horses or some sort of an animal that they used to slide the rocks in huge chunks. Just to give you an example, it takes about, you can transfer in 10 hours, you can transfer about 30 to 40 rocks of that size in a day.
Okay.
I have a few comments to make.
Yeah.
All the time we are trying to detect or communicate with aliens with the help of electromagnetic signals.
Yeah.
So why not we think about neutrinos or gravitational waves? They have much longer range and not absorbed in the atmospheres and so on. So maybe the aliens might be trying to communicate with the neutrino signals, which we are not able to detect. What do you think of that kind of an idea? Thank you.
You are completely correct. We are not, first of all, there are two reasons here. We're looking in that kind of data to see if there is any signal or not. We are just thinking, oh, this could come from solar neutrinos, or this could come from two black holes colliding, gravitational waves. So we are not looking in that. The second and most important thing is that what are we going to look for? What is the signal that looks like from an alien civilization? We know what is alien signal looks like in radio waves, right? Because we have studied it. We know we send it in radio waves. So we know what is a technological civilization can send. We also know what to look for in the atmosphere of a planet to look for life, oxygen, water, ozone, methane, these kind of things. We know what to look for. If there is a neutrino emission coming to us, if there is a gravitational wave coming to us, what are we going to look for? What is the matching thing? Our memory works by matching things, right? I recognize, Professor Usha here, for example, because I've seen her before. That's how I'm matching these two. We can recognize data in the radio waves because, this radio wave looks like the radio waves we send. Oh, maybe that's how alien civilizations communicate. But we are not emitting neutrinos. We are not emitting gravitational waves. So what is the matching thing? Which one we want to look for? So that is the bigger problem. Even if they are sending it, we can't recognize them.
Sir, I have one general question, sir. Like, how do you define life? So, human beings are matter plus consciousness.
Right. So every living being probably has some consciousness, I believe, because they are living beings.
Yeah.
Life is just, if you ask me for the purpose of my own research, small research work, it is probably something that replicates itself. And so if you find an artificial intelligence probe that replicates itself, and if you ask me the same question, do you think that is life? I'll say, yeah.
Sir, I mean, it is biological process is repetition, right?
Correct.
See, we have the greatest ability of speech, right? So other animals do not speak, right? So this thinking, consciousness, all these things, right? So matter plus consciousness is life. I'm not telling the styles of life or whatever, enjoying being born, enjoying eating and getting died. I'm not asking such kind of things. I mean, basically life, I mean, dynamics, we are locomotives and things like that. So basically that needs to be better understood. It's a sort of philosophical also.
That's right. So one of the things, do you think, so there are dolphins, for example, they are the second most intelligent life on this planet. They have communication. We don't understand their communication. Just like, they may not be able to understand what we are talking because its language is different. But they are one of the most intelligent species on Earth. After humans, either it's dolphins or chimpanzees are the two most intelligent species. So they have their own language. So they may be able to think, they may be thinking about, philosophical questions that we don't know. We think that, because they live in the wild, because they are part of the animal kingdom, we think they cannot be having this kind of a consciousness. So it is important to understand what our conscious level will help, but at the same time, we have to be open to the perspective that there may be intelligent life already that is not humans on Earth.
Yes, sir. I mean, I'm asking like, what happens after death? I mean, after death, it is only bodies matter.
Yeah.
And what is this process of transformation between being alive and death? What makes, what biologically, molecularly, what level, what changes are taking place in the body? This is a very deep question. I mean, probably we don't have answer, but I'm putting across the thing.
That's good.
I mean,
that's good. I mean, someone may be able to answer it, but that's a difficult question to answer, actually.
Yes, sir. Yes, sir. Yes, sir.
When you're talking about exoplanets, we are talking about exo-life. Because planet, if you are trying to discover something, we are trying to find whether life is there. So it is always a very thrilling and wonderful experience that we always relate life and planets. In the same manner, the life as we said in our Schrodinger equations, we think of matter as both wave and particle. So when it behaves as wave, what does it respond to? When it is a particle, what does it respond to?
That's an even more deeper question that nobody has explored, according to you.
So, thank you, sir. So, Dr. Krishnamurthy, kindly propose the
wonderful.
I think, sir, we see, sir, Nagaraj, okay. I have requested Malavika take over.
Yes, sir. Yeah. I now request Dr. Kamsali Nagaraj, sir, Associate Professor, Department of Physics, to propose the vote of thanks. Over to you, sir.
Before that, I will speak few words.
Yeah, please, sir. We see, sir.
Yes, sir.
Okay. I'm very delighted to have Professor Ravi Kopparapu here in Bangalore University. In fact, Bangalore University is one of the largest, biggest universities in the country in number, we may not be that productive as NASA or this thing. We can be nowhere in comparison to leading institutions of this world. But definitely, we have a set of teachers, we have a group of teachers who have been working very well to our capacity. And much earlier, thousands of years back, we were the best in physics. We were the best in astronomy. We were best in astrophysics. It is only when we discovered, invented, and so many things in physics, the other civilizations were able to do and follow us. But now a situation or an environment is there where we are following other countries, developed countries. And it is even in those developed countries, we have Indians there. For example, if you see the accelerator in Sweden, 10% of our scientists are there in the Swedish accelerator program. And that similarly in NASA or the companies which are associated with NASA, we have a number of Indians who are participating. That means our scientific, life, the scientific behavior in our life and blood is still there across the world. And that we have seen in Ravi Kopparapu now there working from NASA and see there, because whatever we talk, whether it is philosophical or whether it is scientific or whether whatever method and whatever roadmaps we are doing, that roadmaps are really superior, and it has come from our ancient traditions that we have been able to do well, and we are not far away that we will regain our lost scientific traditions in this country. And Ravi Kopparapu, we are very happy that you have come today morning. Even though it is just 8 o'clock, 9 o'clock in the morning, you have done wonderfully well, and I am delighted with to hear your lecture. Though I just spoke to you for about 15 to 20 minutes, I am actually thrilled, and it is an awesome lecture delivered by you, sir. Thank you very much for being with us in this morning of 8th December 2020. I'll remember this is a milestone in the University of Bangalore. Thank you very much, sir.
Thank you.
Thank you, Vice Chancellor, sir. Since Vice Chancellor sir has briefed about the Ravi Koppar, sir, Ravi Koppar, we are delighted to have your talk, and you have taken us to all the parts actually in explaining the exoplanet and that part. Thank you very much for your sparing your time, valuable time. And whenever you are being in India, we make visit to the Bangalore University. We would like to see you and also have to listen to you in person actually. Thank you one and all. We'll move to the next sessions, maybe the common session where Malavika will take care. Malavika?
Yes, sir.
So thank you, Ravi Kopparapu.
Thank you.
Thank you, sir. Ravi Kopparapu. Thank you so much.
Thank you again. Thank you.
Good night, sir.
Good night. Should I log out now?
Yeah, we can
You
log
can
out.
stay back. I mean,
Yeah,
there will be parallel sessions
We'll
now.
be happy. We'll be very happy to have you continuing with the session.
Yeah.
It's your convenience, sir.
Right.
Yeah, that's up to you, sir.
It's a bit.
That is
late,
parallel.
so-
There is a parallel session, sir, for physics now.
Okay. Sorry.
Yeah.
I will leave
You can. We'll send the link, sir. You can join parallel sessions also.
Okay. So yeah.
Dr. Later on, we have talk by Dr. Annapurni Subramaniam, sir, at 10:30 in the same link. So he'll be talking. Director of Indian Institute of Astrophysics.
Okay.
So Indian Space Programs, he will be talking.
Okay. Great.
So I will send you the link, sir.
Okay. Sounds
If
good.
it is very late, just take your convenience, sir.
Sure.
Yeah.
Sure. Thank you
Thank
again.
Yes, sir. Thank you.
Thank you one and all for come here actually.
Yes.
The session will go for the next session.
Okay.
Thank you,
now-
madam. Yeah.
Saka matadido kamsalina.
Yes, sir. Enough, sir. Yeah, you spoke very well. Spoke very well.
Sir,
I was talking about life.
Yes, sir.
I was talking
Yes, sir.
about life and astrophysics without